So the first thing we're going to do is a little review, because tomorrow we're going to have a quiz. This is work. What's the quiz going to deal with? Well, take a wild guess. Over exponents, which is what we did yesterday, remember? What kind of exponents did we look at yesterday? Fractional and negative. So we're going to do a little practice to get ready for this quiz. All right? So here we go. First problem, simplify. Okay. So what's the first thing you're going to do with this guy?
We're gonna flip.
Turn him over, because we do that. If you have a negative exponent, the first thing you do is flip this guy right here. Okay? So it's going to become 5/3 to the second. When you flip it, your exponent becomes positive. It doesn't change the exponent. It stays 2, but it becomes positive. Now, this is easy. We're going to square both of those. So the answer to the problem is 5 squared. 25 over 9. That's it. Bingo. Done. Now, the next problem does not have a negative, so we're not going to be doing any flipping. But it does have a fraction exponent. So what do fractional exponents always mean? Radicals. Program yourself. Say it over and over and over again as you're walking down the hall or whatever. Fractional exponents mean radical. Fractional exponents mean radical. And under the radical is the number that has the exponent. And the denominator of the exponent tells me which root I am taking. So this is going to be a square root problem. And I'm going to take it to the first power. So what's the square root of 16? 4. And the square root of 9? 3. Since it's to the first power, it just stays the same, right? If it's to the first power, it does not change. All right, the next one has both a negative and a fraction as an exponent. So who remembers what I told you yesterday when you're confronted with this? Yes, very good, Jack. So the first thing we do is take this guy and write him as 1 over 100. In the original problem, isn't he 100 over 1? So the negative is going to flip him, make him 1 over 100. And the power is 3/2. Do not change your power. All you do to the power is make it positive. Now, it's a fraction. It's a radical. Under the radical is 1 over 100. The denominator tells me this is going to be another square root problem. And this time I am going to cube it. So the square root of 1 is 1. The square root of 100 is 10. And I'm going to cube that. 1 cubed is 1. 1 to any power is 1. Don't change 1. And 10 cubed is 1,000. 10 times 10 times 10. All right. 8/27 to the 2/3. Now, it isn't negative, but it is a fraction. Gotta have a radical. And under the radical will be 8/27. This time, I am going to cube root it and then square it. Cube root of 8, 2. Cube root of 27, 3. And I'm going to square that. 2 squared, 4. 3 squared, Guys, this isn't hard. This is not hard. You can do this. All right, the next one. 5 times 4 to the negative second. Now, what we have to be aware of in this problem is that 5 right there, nothing happens to him. He stays 5. This one, however, becomes what? 1 over 4 squared. All right, you work on that while I forgot to take attendance, so before they yell at me, I'm gonna throw it in here. Real quick. Okay, Leslie's gone. Well, somebody else was gone, OJ and Wyatt.
Oh my god, yeah.
I saw the new triple. I felt it was real well. I woke up this morning, I saw it. And I ran through TikTok.
Okay. What have you done with this? What did you do with 1 over 4 squared?
I got 1/16.
1/16, perfect. Now you're multiplying these, so you might want to think of that 5 as 5 over 1. Because when we multiply straight across. So we have 5 over 16 as our final answer. I don't think I even need to write 6 down. I think you should be able to tell me what the answer to 6 is. Right, there's nothing going on there except we're squaring. So what's that gonna be? 25 over 64. Everybody got that? We just square 5 and square 8. We're not flipping or anything. Now 7 is a little harder. What's the first thing I'm going to do with number 7? Flip it. So it's going to become 4/9 to the 1/2. The negative exponent flips it over. What does the fractional exponent mean? Radical. And what radical is it? Square root to the first power. Square root of 4 is 2. Square root of 9 is 3. Done. I don't even know what the last one's doing on there. 1, oh yeah, I do. 1/2 times, okay, what's 2 cubed? 2 times 2 times 2. If you need to write it down, that's okay. 2 times 2 is 4, times 2 is 8. So this is 1/2 times 8. What is 1/2 times 8? 4. Yep. Because if you multiply it, you get 8 over 2, but you know 8 over 2 is 4. Right? So tomorrow, first thing, we'll take a little quiz that looks like that. Okay? Might not have quite that many problems on it, but it will have this kind of problem on it. All right, everybody good? All right. On to our notes, 3.2. I think I'm gonna skip the first and the second one. I'll come back to those in a second, but let's jump in. I want to get through 2 and 3, and then I'll dig the problems out of the book. To put in there. But let's look at number 2. It says, write an exponential function to describe this situation. Who can tell me? I'm on number 2 in 3.2. I'm in number 2 on 3.2. Who can tell me what an exponential function looks like? Y equals a times b to the x. Right? And what did we say about a yesterday? What is a? The initial value. Whatever this is, it is the initial value. So in problem number A, it says the initial value is 4. So don't I know already that I'm gonna be 4 times something to the x? Now, it is growing, increasing, growing 11%. What's gonna go in that parentheses? 1.11. Because remember, this number tells me, first of all, if I'm growing or decaying. Bigger than 1 means I'm growing. And the amount that it's bigger than 1 is the percentage growth. So if I'm growing 11%, doesn't that number have to be 1.11? That's all there is to it. That's easy. All right, what about B? What's B going to look like? Y equals 0.36 times 1.22 to the x. Because what is this problem supposed to describe? A 22% growth. Okay, now here's where the fun begins. The initial value is 147, and we are decreasing 10%. So what number is going to go in here? Yes, Jack. 0.90 goes in there. Why does 0.90 go in there? It's 10% less than 100, less than 1. Remember, this number tells you how much bigger or small, well, your decay is how much less than 1 this number is. So if I am decaying 10%, then this has to be a 0.9 because that is 10% less than 100. Everybody understand that? I feel like I didn't say that. I know what I'm trying to say. I feel like I didn't say that right. Is that okay? All right. Next, the initial value is 20.8. And again, we are decreasing. And we're decreasing by 4.5%. So this number is going to be what? 0.955. Very good. Because that number is 1 minus 0.045. 4.5% is 0.045. When you see a 90 here, that tells you you're 10% less. When you see a 0.955 here, that tells you that you're 4.5% less. All right, last one. 16 thirds, it's okay, that number can be a fraction, not a problem. 16 thirds and what? 0.58 to the x. Is that all right with everybody? Notice that in none of these problems, this one involved 11%, this one was 22%, this one was 10%, this one was 4.5%, and this one was 42%. In any of those problems, did I actually use, did you see a 0.11 or a 0.22? No, it's attached to a 1. It's either 1 plus 11 or it's 1 minus 10. That's how you get this space right here, always. All right, let's look at some word problems then. The population of Calcville, we're going to need a calculator. These are going to be calculator problems. The population of Calcville started out as 123,000 in the year 2000. It decreases 2.5% per year. And I want to know the population in 2010. Does this this information right here allow me to write an equation like that? What is my initial value? 123,000. Now, what is my rate of growth? My rate of decay is 2.5%. So what am I gonna, that is 0.025. So how am I gonna calculate, or how am I gonna figure out this number right here? 1 minus 0.025. So 1 minus 0.025, 0.975, double check my arithmetic, I think that's right. Remember, we never use 2.5, ever, ever, ever. It's either 1 plus 2.5 or 1 minus 2.5. In this case, minus, because we're using population. Okay? So there's an equation to describe what's happening. Now I need to use this equation to find the population in 2010. Any ideas how I might do that? Make this 10. Because if I make that 10, doesn't that mean I am multiplying by 0.975 10 times? In 2001, 2, 3, 4, 5, every year, I'm multiplying by that. So I get my, very good, I get my calculator out. 123,000, parentheses, 0.975 to the 10th power. Remember, this little button right here raises to the 10th power. Now, these are people, so let's round off to the nearest whole person. So I got 95489, 95,489 people. Now, I do not see a calculator in everyone's hand. I need to see a calculator in everyone's hand. And I need to see you typing on the calculator, see, not just holding it. Alright, so everybody's typing this in. We are not sitting and watching Mrs. Ford. Mackenzie? You already typed it in?
Number 3. This one?
Yeah, read it. I want to make sure everybody can type this in. I tell the story all the time. My kids are all soccer players. I watch millions of soccer games. I am not a good soccer player because all I did was watch. Right? You don't get good by watching. What?
The 10th power on calculator, or what did that be again?
Huh?
The 10th power.
Yeah. Just use this little button right here. Raise it to the 10th power.
Just a little refresher.
So, Kelly, what bothers me is I already explained it. I already wrote it up here and said this is the way you do it. Pay attention. Yes, ma'am. All right, let's try B. The population of Trigville was 9876 in 2005. It increases 12% a year. And we want to know the population in 2013. So we're going to write ourselves a little equation, right? What's that equation going to look like? 9876 times, what goes there? 1.12 to the x power. Now, I want you to think about this for a second. It has to be 1.12 because the population is growing. If all you do is multiply by 0.12, guess what's going to happen? You're going to lose population like crazy, right? You need 1 plus 0.12. All right, so there's my equation. Now, how am I gonna use that equation to find the population in 2013? I'm gonna raise it to the 8th power. Why am I raising it to the 8th power? Because from 2005 to 2013 is 8 years. That's how many times I needed to increase by 12%. All right, so let's type this one in. And again, it's population, so let's make it the nearest person. No decimal people, please. What'd you get? 24,453 people. All right. Now, I'm going to do a couple from the book. I'm going to go back and do part 1. So I'll just give you the pertinent information. We're doing number 1. Which is number 20 in the book. Okay, so in problem number 20 in the book, so in your notes, this is 3.21a. I'm going to write down the information you need. Here's the information you need. You have a table of values, and they look like this. Okay, so here is just a T-chart. It's all, I didn't have to do any figuring, it's just right there. And the directions say to write the equation for the exponential function. Now, write the equation for the exponential function. We did this yesterday, the exact same thing. Only yesterday, we did it with very carefully rigged information because we were doing it without a calculator yesterday. And we're gonna do the same thing. We're gonna find our A and our B. And even though you're given 5 points, everybody recognizes these are 5 points. How many do you need? Just 2. And which one do we always want to use? So we're going to start with this point right here, right? And we're going to plug that in. So 2.3 equals A times B to the 0th. This is my X, this is my Y. This is an ordered pair. The only difference between yesterday and today is, yesterday I gave you 2 ordered pairs. Today you have a T-chart full of ordered pairs. Pick whichever ones you want. But I gave you a hint yesterday and said it's always going to be easier to pick the one that has a 0. Okay? So let's solve this. What's b to the 0th? 1. So this is what happened to us yesterday, right? Isn't your a value just that? So your equation is 2.3 b to the x. All right, now think about yesterday. What did we do yesterday then, after we got to this point? We plugged in the other point, right? Well, yesterday you didn't have a choice. You got to plug in another point. You have a choice. It makes no difference. You can plug in any of them. For me, I think this is going to be the next easiest. Would you agree with me? Because that x is 1. So 2.875 equals, I'm plugging in my x and my y. 2.875 equals 2.3 b to the first. Well, what's b to the first? Just plain b. So how am I going to figure out what b is? Divide. And again, Yesterday, I didn't need a calculator because I rigged everything nicely. Here we have a calculator, we can do this, so what's B? What is it? 1.25? Exactly, or did I have to run that? Exactly. So then I'm ready to write my equation. So my equation is y equals 2.3 times 1.25 to the x. Does that look vaguely familiar to what we did yesterday? We're not gonna be panicked just because, we got a different format. Okay, so one more. Here is the given information for this problem. It's not a table this time. It is literally a graph. And here is what the graph looks like. Trying to get my points right here. And the curve looks like this. That is a picture of exponential decay. That is definitely decaying, right? It's not gonna support that, okay? Now, you're gonna write the equation of that function. So yesterday, I put two ordered pairs in front of you. Today, I gave you a T-chart and let you pick your own two pairs. Now I've given you a graph, but contained in that graph is what? Two ordered pairs, one of which has a zero. So we'll start with that one. So 3 equals A times B with a zero. Right? So 3 equals A times B, or excuse me, A times 1. So A is 3. Okay. So y equals 3 b to the x. Alright, so now what do I need to do? Plug in my other point, which is 1.49 equals 3 b to the fourth. Alright, how do I go about solving that? I'm definitely going to use my calculator, but let's get it set up. How do I go about solving it?
Divide 3.
I have to divide by 3, so 1.49 over 3 equals b to the fourth. Okay, so what's, I bet that's not nice. Oh, I got a low battery notice, time to change batteries. Did you get 0.49, let's just do 4 places, 6, 7? When you did that division? Now, yesterday, we did a lot of problems like this, several like this. Don't we now fourth root? You okay? Although, yesterday, that number was something like a 16 or something where we can find the fourth root, you know? So I'm gonna need my calculator to find the fourth root of this. So I need everybody, okay, you don't have a calculator? Who else doesn't have a calculator? Is yours working? Is Jack the only one? Where's your calculator, Josh? No?
Somewhere in my backpack.
Well, you're gonna owe me 50 cents because you are not prepared for class. This has got to stop. These are low too, see if they'll stay, if it goes off, I'll give you a different Usually when it comes on with that message, you gotta come in.
A.
I bet she would.
What?
Can I go to the bathroom super duper fast?
Wait, what do you mean?
Where's your ring?
It's like not
We
an
had a
actual
meeting this
problem.
morning, we're supposed to discourage this. Is this an emergency meeting?
I guess I could.
Okay, thank you. Okay. All right, we got too many kids wandering the halls. Everybody has to go to the bathroom all the time. Okay, so I get it, if you really have to go, you can go. But if this is just, oh, I'd rather go to the bathroom than do this on the calculator, we're not gonna do that. Okay, so you make the call.
I'll be super fast.
All right, hurry up. Okay, so here's how you're gonna type this in. I need everybody paying attention, okay? Because we're not, I mean, this is a skill we need to know, but it's not part of every problem, so I'm gonna do it a lot. So go to your math, well, wait, first, whatever route you're taking, type that number, so type 4, okay? Then go to your math button, and notice in the list, there is a key, or I should say an option, that looks like this.
That's 5.
Okay, press that one. And then type in the 0.4967 and hit equals. Alright? So that button, X roots. So this time we were doing 4th root, next time we would do 5th root, or whatever root we wanted. That is the button that does odd roots, not square root, you have your own button for, but other things, there it is. Okay? So what did you come up with when you 4th rooted that number?
0.8395.
What is it?
0.8395.
0.8395? So then what is the answer to my question? Y equals, I forgot now, what was my A?
3.
3 times 0.8395 to the x power. Now, when you talk, we're gonna do one more example like this, okay, one more, but before we do it, I wanna talk about, does it make sense that that number right there is 0.8395? Why? Because look at the picture. What did we say is happening in the picture? It's decay. And what do we know about this number in the decay problem? It's less than 1, right? So that makes perfectly good sense for this problem. All right, one more. I want you to practice with your calculator. So I'm going to draw another picture. Maybe a couple more points. So you can do this one over at the margin or wherever you got room. And let's write the equation of this curve. That's the 0.0, 4 and 5.805. 5, 8.05. 5, 8.05. All right. So take a second on your own and see if you can write the equation of that. All right, how are you doing? One more minute, go ahead.
Not what I got. Miss Ford. My calculator just died.
Huh?
My calculator just died. I'm sorry. Very nice. Very nice.
Why are you letting your sister sign here?
Oh, I left mine in my car till we were together today, but she had another one.
I think that's not the idea of having identification, is you're not supposed to wear somebody else's identification. Anna. All right, let's see what we got here. Let's see what we came up with. Your goal is to write this equation, right? So what did you get for your A? 4? Do we need to discuss that, or is everybody good with 4 for A? So that means we are starting, Darryl, are you good with that?
Yes.
All right, so we're starting with this equation. So, take that point, 8.05 equals 4b to the 5th. So what did you do first? Divide by 4, that is going to be step 1. Please don't do anything else. We're going to divide, so 8.05 divided by 4. So I got 2.0125, and I'm going to go ahead, since it terminated, I'm going to go ahead and keep all those decimal places as b to the 5th. Then, to get b, I'm going to have to 5th root, right? So I'm going to type 5, math, x root 2.0125. And I got 1.1501. And then I write my answer. Y equals 4 times 1.1501 to the x power.
Not okay with that at all. I said, you know, 2
Probably
points.
don't have it off unless you have to. Okay?
Can I stick with it?
Okay, so let's, and I can see that happening. I can see that. Because it is, was that.
Oh, yeah, it's good.
There'll be directions. All right, we okay with that? Everybody okay? All right, so 3.2 will be due, on, let's say Thursday, Monday. And we're gonna start 3.3, and I won't do too much of this today. And maybe we'll have time to do a homework problem or two, to get you going. I do wanna say though, as I'm looking at this, that these problems go fast. It looks like there's 28 of them, that looks like a ton. They go fast. Notice what's the very next section say in 3.3? Use your calculator. So if you didn't bring one today, you need to bring one tomorrow, because we're gonna need a calculator for all kinds of stuff, in this, okay? So, right now though, we can set it down, because we are going to start evaluating some logarithms. Okay, now, kids, these are all extremely easy problems. They look, the minute you stick a logarithm in, they look like, oh my gosh, it's so hard. These are all problems that you can do with no no or very little work. These are not going to require much of any effort at all on your part. However, they do require you to know a couple of things. All right, so this very first problem, I am going to show you two ways. All these problems can be done the same way. I'm going to show you two methods. You will choose the method that you like best, or maybe some problems you'll use one method and some problems you'll use the other method. Okay? So here's the first method. My job is to figure out what these are, so I'm going to set an equal to x. Okay? What is x? This is one method. You can do this. When you have a logarithmic equation, it can be translated into an exponent equation like this. It always works this way. Take this number, raise it to this power, and equal it to this number. So let me say that again. Take this number right here, I'm starting with that number, raise it to this power, and set it equal to this number. Mr. Miller, our old, not the physics guy, but the man my age who taught math for years here, Mr. Miller, he used to call this log rolling, kind of rolls around. Okay, so we start with this number, raise it to that power, equals this number. Well, wait, 5 to what power is 5? 1. The answer to this problem is 1. It's that easy. It's that easy. So if we do that with this one, you start here. So 4 to this power equals 16. 4 to the x equals 16. So 4 to what power is 16? 2. 4 squared is 16. So the answer to that problem is 2. Now let's come down here and do this one. We'll do my log problems first. Let's come down here and do this one. Okay? So if you're going to write it as an exponent equation, you're going to say 4 to the x equals 1/16. Okay, look, 4, we start here, 4 to the x equals 1/16. Now, this one's a little bit harder. 16 is kind of special though, right? In terms of 4, what's 16? Well, 4 squared. So does this not say 4 to the x equals 1 over 4 squared? Isn't 16 4 squared? But it's 1 over. What does that mean? If it's 1 over, doesn't that mean its exponent is negative? So 4 to the x equals 4 to the negative second? So what's the answer to the question? Negative 2. Negative 2. It's a little harder. Gotta know your exponents. So this answer is negative 2. It's 1 over, so I knew it was gonna be negative. And since 16 is 4 squared, it is negative 2. Let's try this one. Scary. Not for us. Let's log roll it, as Mr. Miller used to say. How's this roll? 6 to the x equals the cube root of 6. Now wait a second. What power is a cube root? Not 3. It's not 6 cubed.
What's 1/3?
1/3. Because what do I know about radicals? Radicals are fractional exponents. Backwards thinking. Fractional exponents are radicals, so radicals are fractional exponents. So 6 to the 1/3 is the same as the cube root of 6. Would you agree with that? So the answer to this problem is 1/3. Now, again, try to put, I know it's day one, we're gonna practice this a lot, but try to put these pieces together. This had a 1/, and our answer came out to be negative, because negative exponents are 1/, flip them. This one had a radical, and our answer came out to be a fraction, because fractional exponents are radicals. Right? Okay. Let's do this one next. This one's easy. Anybody want to hazard a guess what the answer to this is? 7?
2.
2?
Yeah. Yeah.
2?
That makes sense.
Because this says 7 to what power is 49? And 7 to the 7th is big. Everybody get that it's 2? Alright, let's grab this one right here. This one's gonna take you guys can figure this out, you're smart people. What does this equation say? 4 to the x equals 1? 0, because anything to the 0 power is 1. How do you get a 1 out of a 4? You raise it to the 0 power. So the answer to this is 0. 4 to the 0. Now, would it matter if I changed this to a 5? Would it still be 0? So really, if this is a 1, that number can be anything, and the answer is going to be 0, because the only way to equal 1 is to raise to the 0 power. Right? Well, I'm trying to do all my log problems first. Okay? Now, I need to talk about ln. So I've got this one left. Get all my log problems. So I've got a couple in my list that I wrote down. I've got, I guess, just 2. ln. So we need to talk a little bit about what the notation is. So if you have LOG and no base attached, now in all of my examples, oh wait, did I skip 4?
Yeah.
I think I skipped 4, so I need to talk about that one too. Log of 1,000. And I did all the way down to 9. I'm gonna go ahead and do 10 just to wrap it up. Okay, so we did, this is number 3, this is number 4, this is number 6, and number 10. And then we'll stop on this for today, okay? Notice that these 2 LOG problems do not have a little base number down there. Whenever you see the symbol LOG with no base, now it can be a 7, it can be a 5, it can be anything, but if there's not one written, you know it is a 10. When there's no base written, it means base 10. These are called common logs, and their symbol is LOG. So if there's a base there, great. But if there's not, and it says LOG, put a 10 in. Okay? So back to this problem number 4. There's no base, so I'm gonna put a 10 in. I'm gonna set it equal to x and figure out what it equals. So 10 to the x equals 1,000. So just think about it for a minute. 10 to what power is 1,000? 3. So the answer to the problem is 3. Number 10. There's no base on that either, so I'm gonna give it 1. 10 to the x equals 1/10. Think about that now. Don't make this hard. You know this. 10 to what power would be 1/10?
-1.
-1. -1. Isn't that how you get 1 over? So the answer to that one is -1. There's nothing different about these problems except the base. You need to know to put the base in there. Now, what does ln mean? Well, the symbol ln means natural logarithms, and their base is e, the number e, 2.718, the number e. Bless you.
Thank you.
Okay? So when I look at problem 3, I am going to rewrite this as log base e. That's what ln stands for, log base e of e to the 3rd equals x. So ln becomes log base e. Now let's rewrite this. Start here, so e to the x equals e to the 3rd. Well, that's a no-brainer if I ever saw one. E to what power is e to the 3rd? 3. You guys have been great today. One more. Rewrite the problem as log base e of 1 over e cubed. Okay, we're going to rewrite our ln's until we get used to it. We're going to rewrite our ln's as log base e. Now, what does that equal? All right, here we go. Start right here. E to the x equals 1 over e cubed. Okay, you know this. What power do you raise it to get 1 over e cubed? -3. So your answer is -3. All right, you guys are having a lot. Let me get my calculator back. Maggie, oh, you're not Maggie, you're Anna, but you're, Maggie says Maggie. Somebody else's name.